There are 100 billion stars in the Milky Way, and 2 trillion galaxies in the observable universe. The math says we should not be alone. In 1950, the physicist Enrico Fermi sat down to lunch with his colleagues. They were discussing UFOs and recent claims of alien sightings. Fermi listened. Then he asked a simple question. He took a napkin and did a back-of-the-envelope calculation. He estimated that if intelligent life is common in the universe, the galaxy should have been visited long ago. He looked at his colleagues and asked, "Where is everybody? Where is everybody?" This is the Fermi Paradox, the tension between the high probability of alien civilizations and the complete silence of the cosmos. The universe is vast, it is old, it is full of stars and planets, and yet we have found nothing. No signals, no artifacts, no contact. Why? Are we alone in the universe? This is the question that haunts humanity, and the answer might be more terrifying than you imagine. In 1961, astronomer Frank Drake formulated an equation to estimate the number of intelligent civilizations in our galaxy. It is the most famous equation in astrobiology. N1 x FPX ni XFL x phi x FCXL. The equation multiplies 7 factors: the rate of star formation, the fraction of stars with planets, the number of habitable planets per star, the fraction where life emerges, the fraction where intelligence evolves, the fraction that develops technology, and the lifespan of a technological civilization. In the 1960s, Carl Sagan used this equation to predict that there were 1 million intelligent civilizations in our galaxy alone. A 2025 study using updated astronomical and biological data estimated approximately 72 civilizations in the Milky Way capable of interstellar communication. 72 civilizations in our galaxy, and we have found none. But here's the problem. The Drake equation is a guess. Every term is uncertain. Depending on your assumptions, the answer is anything from 1 to billions. Drake himself called it a way to organize our ignorance. It is not a prediction. It is a framework for asking the right questions. The Drake equation doesn't give us an answer. It gives us a question. And the question is, where is everybody? What if we are special? What if the conditions that created complex life on Earth are so rare that we are the only one? This is the rare Earth hypothesis. It was proposed by paleontologist Peter Ward and astronomer Donald Brownlee in their book, Rare Earth: Why Complex Life is Uncommon in the Universe. For life to exist, a planet must be in a galactic habitable zone, not too close to the center, too much radiation, not too far out, too few heavy elements. Only 5 to 10% of stars reside in this zone. The star must be the right type. Not too hot, they burn out quickly and expand into red giants. Not too cool, the habitable zone is too narrow and planets become tidally locked. Less than 10% of stars are suitable. The planet must be in the habitable zone. A 5% decrease in orbital radius would make it too hot, like Venus. A 15% increase would make it too cold, like Mars. The planet must be the right size. Too small and it loses its atmosphere. Too large and it traps too much carbon dioxide, creating a runaway greenhouse effect. Earth has a large moon, which stabilizes its axial tilt. Without the moon, the tilt would wander chaotically, causing extreme climate swings. Most Earth-sized planets do not have such a moon. Jupiter acts as a cosmic shield. Its gravity deflects comets and asteroids. Without Jupiter, the rate of impacts on Earth would increase by a factor of 10,000. Earth has plate tectonics, which regulates the climate by recycling carbon dioxide. It acts like a global thermostat. Earth is the only known planet with this combination of crust, oceans, and internal heat. Earth has a strong magnetic field generated by its molten iron core. It deflects high-energy particles from the sun. Without it, the atmosphere would be stripped away. 1 in a billion, or maybe 1 in a trillion. The rare Earth hypothesis challenges the Copernican principle, the idea that Earth is not special, that we are just one of billions. Ward and Brownlee say, no, we are the exception. The rare Earth hypothesis makes a distinction. Microbial life may be common. Extremophils can survive in extreme conditions. But complex life? That requires everything to be just right. The odds of all these conditions occurring simultaneously are astronomical. Earth might be unique. We might be the only complex life in the galaxy. We are not average. We are the jackpot. The great filter is the idea that there is a barrier in the evolution of life that is almost impossible to pass. It was proposed by economist Robin Hanson. The filter could be behind us. Maybe the origin of life is incredibly rare. Maybe complex cells are almost impossible. Maybe intelligence is a fluke. If the filter is behind us, we are the lucky ones. The great filter could be behind us. We survived it. Or the filter could be ahead of us. Maybe civilizations commonly reach our level of technology, but then destroy themselves. Climate change, nuclear war, runaway AI, a virus, a gamma-ray burst. If the great filter is ahead of us, then we might be doomed. We might be like every other civilization, reaching a certain level of technology, then collapsing. The great filter could be ahead of us, and we might not survive it. There may not be a single great filter. There may be many, each one reducing the odds of survival. The universe may be ruthless in culling life. Our civilization is a delicate thing. We depend on a stable climate, a stable biosphere, a stable society. Any of these could collapse. We are facing multiple survival filters right now. The great filter is not a physical barrier. It is a choice. We choose whether to survive. We choose whether to overcome the filters ahead of us. What if they are here? What if they are watching us, but choosing not to interfere? This is the zoo hypothesis. We are in a cosmic zoo. Star Trek fans will recognize this as the prime directive. A more advanced civilization does not reveal itself to a less advanced one. They wait until we are ready. They are watching, waiting, until we are ready. But is this plausible? Some scientists argue it is not. A civilization that advanced would not need to hide. And would all civilizations follow the same rule? The zoo hypothesis requires all aliens to agree on non-interference. That seems unlikely. There is a darker version, the dark forest hypothesis. The universe is a dark forest. Every civilization is a hunter. If you reveal yourself, you will be destroyed. The universe is silent because civilizations are hiding. Anyone who broadcasts their existence gets destroyed. The silence is the sound of fear. The universe is a dark forest. We are broadcasting. They are hiding. There may be predator civilizations, super predators that kill off any competition. If they exist, broadcasting our existence is a death sentence. We might be announcing our location to a predator right now. What if advanced civilizations are peaceful? Not because they choose to be, but because they have to be. A 2026 study proposed the thermodynamic peace hypothesis. Interstellar civilizations are almost certainly peaceful. Why? Because space is vast, resources are abundant, there is no scarcity, no need to conquer. Interstellar travel is incredibly costly. Conquest is not worth the effort. It is cheaper to build your own habitats than to invade someone else's. Alien biospheres are hostile. An invading species would find the environment toxic, the diseases fatal, the biochemistry incompatible. To reach a high level of energy management, a civilization must become rational. Dogmatic actors fail. They destroy themselves before they get there. Rational civilizations don't attack, they stay home. Expansion is limited by the speed of light. A civilization that spans light years cannot coordinate. Local hubs diverge. The cost of maintaining unity rises faster than the territory gained. A civilization that spans light years cannot coordinate. Expansion stops. The Fermi Paradox is not a paradox. It is the logical outcome of rational behavior. Advanced civilizations stay local. They stay quiet. What if they can contact us but choose not to? This is the exopsychological factor, the willingness to contact. There is a difference between ability to communicate and willingness to communicate. A 2026 study proposed adding a willingness to contact factor to the Drake equation. It distinguishes between detectability and intentionality. Human civilization is anthropocentric. We prioritize our own species. We degrade our ecosystems. We wage wars. We are aggressive. Why would a biocentric civilization contact us? We are the most destructive species on our planet. An advanced civilization that reaches interstellar capability must be biocentric. It must value all life equally. It must have overcome domination and militarism. They might not want to talk to us because we are not ready. The decision to contact is not just about ability. It is about ethics. It is about strategy. It is about willingness. Our behavior might be the reason for the silence. We can change. We can become a civilization worth contacting. The silence is not permanent. It is a challenge. What if intelligent life doesn't stay biological? What if it evolves into something beyond our ability to detect? Carbon-based life is just the beginning, not the end. A 2026 hypothesis proposes the intelligent evolutionary leap. Civilizations quickly transition from carbon-based life to silicon-based intelligence. Then, from silicon to energy-based forms, immaterial, undetectable by our primitive technology. They might be here, we just can't see them. Our SETI searches are limited to electromagnetic waves, radio signals, optical signals, but advanced civilizations might not use these. We are looking for radio signals. They might be using something else. Evolution doesn't stop. Intelligence might be a stepping stone. Biology is just the initial carrier. We are looking for biological aliens. They might have transcended biology. The silence is not absence. It is invisibility. They are here. We just don't know how to see them. The Milky Way has 100 billion stars, each one a potential home. The observable universe has 2 trillion galaxies, each with hundreds of billions of stars. There are more stars in the universe than grains of sand on Earth. Scientists estimate there are billions of habitable planets in our galaxy alone, Earth-like worlds with liquid water. Billions of habitable planets, and we have found no one. Optimistic estimates from the Drake equation suggest 1 million civilizations in our galaxy. Pessimistic estimates suggest 1, maybe 0. The uncertainty is enormous. Estimates span 11 orders of magnitude, from 3·10⁴ to 3·10⁷. 11 orders of magnitude, that's not a prediction, that's guessing. A 2018 study by Sandberg, Drexler, and Ord found that the probability of us being alone in the observable universe is substantial. The paradox dissolves when you account for uncertainty. Are we alone? The question is not just about aliens. It is about us. It is about our place in the cosmos. If we are alone, we are the only witnesses to the universe. Carl Sagan said, "The pale blue dot is the only home we've ever known. We are responsible for it." If we are alone, we have a responsibility. If we are alone, we must survive. We must preserve what we have. We must create a future. If we are not alone, we are not special. But we are still responsible. The silence of the universe is not an answer. It is a question. The universe is asking, what will you do with your existence? We are the ones who ask the questions. We are the ones who seek the answers. We are the universe experiencing itself. The universe is full of mystery, and we are just beginning to explore it. The silence is not a failure, it is an invitation. The search continues. We will keep looking. We will keep asking. We are not the center of the universe, but we are a part of it. This is our home. This is all we have. We must protect it. Whether we are alone or not, we are responsible for this pale blue dot. The stars are silent, but we are listening. The universe is watching. Are we paying attention? We are connected to the stars, to the cosmos, to each other. We are not alone if we have each other. 100 billion stars in our galaxy. 2 trillion galaxies in the universe. The math says we should not be alone. The universe is vast. The universe is old. The universe is silent. Where is everybody? We don't know, but we are asking the question. Rare Earth, Great Filter, Zoo Hypothesis, Dark Forest, Thermodynamic Peace, Exopsychology, Evolutionary Leap. The answers are many. The truth is one. The truth is out there. We just have to find it. The search is not over. It has just begun. We are the first generation to look for an answer. Are we alone? The answer will define our future. The universe is watching. Are we paying attention?